simulation. Simulation analysis. Simulation analysis, AFM. Simulation analysis, AFM. And I would want us to refer to November 2016. November 2016, question number 1, boy. November 2016, question number 1, boy. For those of you who have got this kind of revision kits, you will simply go to page number 11. Page number 11. Page number 11. Page number 11. Now, ladies and gentlemen, the most important thing that you're supposed to know under simulation at our level, number 1, is how do we ascertain what we call the random number ranges. If I'm reading this, how do we get random number ranges? Random number ranges. How do we get random number ranges? So remember that simulation is normally applicable to probabilistic variables. Variables that you're not so sure of how their figures will look like. If, for example, somebody wants to go into business of selling this kind of pens, ladies and gentlemen, one of the things that will really be troubling you will be how much price do we charge for our pens, which we will be selling. So of course, I'll have to go outside there to my competitors, to ladies and gentlemen, and sample out. Of course, some of these people are selling their pens for 20 bob, or rather for 10 bob, others 20 bob, others 30 bob. So given the frequencies, I will be able to get the probability. So for example, we have our probability as 0.3, 0.4, 0.3. So if you're given this kind of a distribution, and then you are required, ladies and gentlemen, here to determine, you are required to determine random number what here ranges. Determine a random number ranges. They want you to get the random number ranges. Random number ranges are also known as what here classes. Random number ranges are also known as classes. Could you be kind enough and please try getting the random number ranges for us out of this question? Out of this question, shall we be able to get random number ranges? Very easy. The first thing that we shall do, ladies and gentlemen, is to ascertain what we call the cumulative. Probabilities. So come and accumulate these probabilities downwards. So then what do we have, ladies and gentlemen? Accumulation basically is aggregation. We are aggregating these probabilities downwards as we encounter them. So like the first one here is 0.3. So 0.3 plus 0.4 gives us 0. What here, somebody? That gives us 0.7. So we are aggregating them. So this 0.3 aggregate, lump it here, lump it here. So 0.7 plus 0.3, that gives us 1. What here? That gives us 1.0. That gives us 1.0. Now, ladies and gentlemen, the moment I have my cumulative probabilities, the next thing that I will do is to come and ascertain the random number ranges. So come and give us the random number ranges. So if you are able to remember this from your section 4, we said in section 4 quantitative analysis that the random number ranges digits normally depend on what we call the decimal places. The decimal places. If we have got one decimal place probabilities, then we shall be having what we call the concept of one digit. So one decimal place will always be given by, or rather captured by, single digits. So my single digit here will run from 0 all the way to 9. My single digit here will come from 0 all the way to what here, somebody, to 9. So these are single digit. The ending is also a single digit. Now listen to me very well. When we have two decimal places, we shall be talking of 2 digits. And our 2 digits will look like this: 00 all the way to 99. These are the 2 digits we're talking about. 00 all the way to 99. 00 all the way to 99. 00 all the way to 99. And of course, if it's 3 decimal places, and the same will follow 3 digits, etc. This may not make sense to most of us until we look at an example. So like now here, ladies and gentlemen, we have our cumulative probabilities having how many decimal places? These are single, one decimal place. So if it's one decimal place, then my digit here will be single. So like now the first class, listen and listen to me very well. The first class, ladies and gentlemen, I'll talk of 0 all the way to, look at the number that we have here. The number that we have here is 3. You read it as if it's a whole number. Listen and listen to me very well. How will I be able to attach, how will I be able to find out the upper limit for this? To find out the upper limit, we shall read this 3. This figure as if it's a whole number, which is 3. And to get the upper limit, after you've read this as if it's a whole number, what you do, you take 3 minus what? 3 minus 1. So 3 minus 1, ladies and gentlemen, 3 minus 1, that gives us what here? Gives us 2. So to get the upper limit, what have we said? You read a number as if it's a whole number, and then you subtract what here? Somebody, you subtract 1. Now, ladies and gentlemen, listen and listen to me very well. The next class now will begin from the next number after what here? Somebody after 2. On the number line, after 2, we have number 3. All the way to the upper limit. How do we get the upper limit from this? I will read this as if it's a whole number, which is 7. 7 minus what here? 1. So 7 minus 1 gives me what? Somewhere there gives me 6. Now after 6, the next number will be 7. So 7 all the way to 10 minus 1. 10 minus 1, that gives me what? Somewhere there? That gives me 9. 10 minus 1, that gives me 9. Now, ladies and gentlemen, listen and listen to me very well. What if you went to an exam, and got the following, probabilistic distribution? This probabilistic distribution is X, which could either be 10 or 20, and then they have given us probabilities of 0.40 and 0.60. So if they give me X there, X which is probabilistic, which could either be 10 or 20 with these probabilities, and then they want us to find the random number ranges. How will I go about this? Ladies and gentlemen, what I'll need to do is to come and ascertain the cumulative what here? The cumulative probabilities. So we'll have to ascertain the cumulative probabilities. So cumulative probabilities, what do we have here, somebody? So we are accumulating these figures downwards. So we have 0.40, and then of course we have here 1.00. When you add, I hope you guys are able to follow. When you add 1.00. Of course, ladies and gentlemen, in the simulation, we are quite sensitive to the decimal places. You can see that these people have a level of accuracy of 2 decimal places. Don't tell us that this 0 is not significant to us. These zeros here mean a whole world. They are very significant, ladies and gentlemen. So having gotten the cumulative probabilities, now we should be able to come and pull out what we call the random number ranges. So random number ranges, ladies and gentlemen, given that these are 2 decimal places, now we shall talk of 2 digits. 2 digits will be 00, all the way to the upper limit. How do we get the upper limit? The upper limit will be 40. You read this as if it's a whole number. This will be 40 minus who? 1. 40 minus 1, ladies and gentlemen, gives me what here? 39. 40 minus 1 gives me 39. Now, ladies and gentlemen, the next number after 39, which will be defining the starting of my next range, the starting of my next class, is 40. So 40 all the way to 100. 100 minus 1. 100 minus 1 will be what here? Somebody 99. 99. So the last illustration for us is illustration 3. What if you are given here y equals 30 and 80? And then these people will come and they give us probabilities of 0.10 and perhaps 0.90. I would want to see whether there is a good student in this particular class who will be able to give me the random number ranges out of this. Now, ladies and gentlemen, here we are. Somebody who is correct here, look at what people are correct did. The first thing is to come and ascertain our cumulative probabilities. So cumulative probabilities are adding these figures downwards. So we have 0.10. Of course, when you plug in this here, you'll end up getting 1.00 like that. Having gotten the cumulative probabilities, the next thing will be for us to get the random number ranges. So how will our random number ranges look like? 2 digits. So our 2 digits will be 0, 0. You have to start from there, all the way to 10 minus 1. So 10 minus 1 should give me 9. But you see, I can't write 9 alone. I have to be consistent with my number of digits. So I have to come and say here 09. So of course, after that, ladies and gentlemen, the next class will begin from the next number, which is 10. So 10 all the way to 100 minus 1. 100 minus 1 gives me what? Somebody there gives me 99. 100 minus 1 gives me 99. Now, ladies and gentlemen, having gotten this very well, I would want us now to look at our question, which is November 2016, question number 1, boy. November 2016, question number 1, boy. Don't forget, for those of you who have already purchased our RCM's books, you simply go to page number 11. Page number 11. You simply go to page number 11. So page number 11, November 2016, question number 1B, we are told SKB Limited. SKB Limited is considering a proposal to manufacture a new drug named Millennium. The drug will be manufactured using a machine which will cost shillings 13 million. The cash flows and the drug life relating to Millennium have been estimated as stochastic exogenous variables with the following distributions. So they have given us the annual after-tax cash flow. We have the probabilities. We have the drug life in years. We have the probability like that. We are told the minimum required rate of return from this investment is 16%. The company has approached you as a financial management expert to perform analysis of the above project. So required, using the following random numbers, perform 10 simulation runs of the net present value of this project. And then they want us to determine the expected net present value of the project. Now, ladies and gentlemen, here we are. This is a very straightforward question. Very straightforward question. Simulation, any examiner who gives us a question on simulation analysis is an examiner who is wishing us success. Is an examiner who is wishing us success. The very first thing that we need to do here is to ascertain the random number ranges. So mentioned there, the first thing that we do there is to ascertain the random number ranges. So come and give us the random number ranges. Random number ranges. Random number ranges. So random number ranges. So random number ranges, what do we have here? We have, this is simulation. Because it's advanced financial management. The question is November 2016. November 2016. Question number 1B, like that. So under random number ranges, ladies and gentlemen, we will need these probabilistic variables. Those variables that are giving us problems under simulation, they are called probabilistic variables. So under these probabilistic variables, the first one that I'm able to see there is the cash flow. So we have cash flow, ladies and gentlemen, which could either be 1,000, 1,500, we have 2,000, 2,000, 2,000. The next one, ladies and gentlemen, is 2,500. The next one is 2,500. The next one, ladies and gentlemen, is 3,000, 3,000. Then we have 3,500. Then we have 4,000, like that. Now, ladies and gentlemen, here we are. Come and give us our probabilities. Give us our probabilities for this particular variable. So we have here 0.02. We have 0.03. We have 0.15. We have 0.15 again. We have 0.30. We have 0.20. Lastly, 0.15. From there, I'm able to see that the drug life is also what here is also probabilistic. So we have the drug life. So the life in years. the life in years. If my cameraman can see me all the way up to down here, we have 3, 4, 5, 6, 7, 8, 9, 10. So we have the probabilities being given. The probabilities for 3, we have 0.05, we have 0.10, we have 0.30, we have 0.25, 0.15, 0.10, 0.03, we have 0.02. So, ladies and gentlemen, once I have identified those troublesome probabilistic variables for simulation purposes, the next thing will be for us to ascertain, the cumulative probabilities. So come and give us the cumulative probabilities. So cumulative probabilities, what do we have? The first one is 0.02. We have here 0.05. We have here 0.20. Remember, you have to be consistent with decimal places. Ladies and gentlemen, we have 0.35, 0.65, 0.85, and then we have 1.00 like that. So the same with this other variable, give us the cumulative probabilities. So we have 0.05, we have 0.15, 0.15, we have 0.45. What am I doing? I'm simply aggregating, I'm simply accumulating, I'm simply plugging in the probabilities as I come across them, I'm aggregating them. So this gives me 0.70, this gives me 0.85, this gives me 0.95, this gives me 0.98, and lastly we have 1.00. Now, ladies and gentlemen, if that is the case, we know after cumulative probabilities, the next button is called random number ranges. So come and give us the random number ranges. Give us the random number ranges. So random number ranges, look at this. These are how many decimal places? 2 decimal places, and hence we shall talk about how many digits? 2 digits. 2 digits. 2 digits. So come and talk about 00 all the way to what here? Somebody want to give you like 2 minutes. You finish this. Finish the entire thing, ladies and gentlemen, for us. Okay, ladies and gentlemen, here we are. So what we shall do, I'm so sure you guys must have finished. So we say that these are 2 decimal places. And if there are 2 decimal places, now we need to come and work with what here? The 2 digits. So 00 all the way to the upper limit. How do we get the upper limit? I will read this as if it's a whole number, 02. So 02 minus 1, that will give me 01. From there, the next number will be 02. 02 all the way to 0 what here? Somebody to 04. Because I'm reading this as if it's a whole number. So the next one will be 05 all the way to 20 minus 1. 20 minus 1 gives me 19. So from there we have 20. Next number after 19 is 20. So 20 all the way to 34. So we have 35 all the way to 64, 65 all the way to 84, 85 all the way to 99 because of 100 minus what here? Minus 1. So ladies and gentlemen, we have random number ranges here. Random number ranges, we have 00 all the way to 05 minus 1, which is 04. The next one will be 05 all the way to 15 minus 1, which gives us 14. So we have 15 all the way to 44. We have 45 all the way to 69. We have 70 all the way to 84. Then we have 85 all the way to 94. From there we have 95 all the way to 90 what here? 7. Lastly, we have 98 all the way to 99 like that. 98 all the way to 99. Now, ladies and gentlemen, having been able to assign random number ranges like these, the next thing that we need to do is to come here, we come here, and ascertain what we call the simulation worksheet. So the last step is for you to come and give us what we call the simulation worksheet. So give us the simulation worksheet. Remember, the first title of a simulation worksheet will be run number. So we have the run number. As this examiner told us how many times they're going to run. Have they given us the number of runs? Yes, if you look at this November 2016, question number 1B, they have told us using the following random numbers, perform 10 simulation runs. So they want us to run 10 times. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, ladies and gentlemen, remember that for each run, we would want to predict these troublesome variables. The variables that we are not certain of, their figures. So we need to predict the troublesome. Like now, we don't know how much cash flow we're going to get. We don't know how much, or rather how many years our drugs will have. So number of years. So what we will do to estimate them, we normally use the random numbers given by the examiner. So you pick a random number for you to be able to give us, ladies and gentlemen, a cash flow. You pick a random number for you to get a cash flow. Again, come and pick another random number for you to be able to give us number of years. For you to be able to give us number of years. So remember the troublesome variables, all the variables that you've been able to ascertain their random number ranges that are probabilistic, they have to be predicted using random numbers. And the random numbers will always be given to us by our examiners. Random numbers will always be given to us by our examiners. So ladies and gentlemen, let's begin by first of all ascertaining these troublesome figures. And I can only ascertain them, I can only predict them using the random numbers given. So random number given, I can see the big one. The first one that this examiner has given me is a big one. It's random 5397 as a block. But of course, being a student of finance, I know that my random number range is here over how many digits? 2, 2. So then this figure has to be subdivided into 2 digits. If you look at down there, this examiner has given us the random numbers to use. And the block one, the first block one he has given me is 5397. 5397. So I need to come and do what here? Somebody cut, subdivide this, apportion this into 2 digits at a time. 2 digits at a time. 2 digits at a time. So therefore, we'll have here the first random number will be 53. The second one here will be 97. 97. So please go to the second run number. The second run number, if you are able to follow, I will use 66 versus 99. 66 versus 99. The next one, I'll use 30 versus 81. 30 versus 81. The next one, I will use here 1909. The next one, I'll use 3167. 3167. The next one, ladies and gentlemen, I'll use the 8170. 8170. The next one will be 3875. 3875. The next one, ladies and gentlemen, will be 4883. 4883. The next one, ladies and gentlemen, will be 9033. So we have here 9033. And then lastly, ladies and gentlemen, will be 5852. 5852. Now, having put those random numbers down that nicely, the next thing that I will do is now to come and pick the cash flows, for example. So I'll ask myself, when we have random number 53, how much cash flow are we going to enjoy? So 53 in the ranges of cash flows, 53 is right here. 53 is right here. 53 is in between here, meaning that the cash flow applicable here will be 3,000. I can even finish for the cash flows fast. So 66 is seated well in between here, 66, which gives me a cash flow of 3,500. I can go ahead and finish all the cash flows. So random number 30 is well here, which translates to 2,500. 2,500. So now I need to move with speed 19. 19 is here, 2,000. 31 is in here, 2,500. 81 is in here, which will give me 3,500. 38, ladies and gentlemen, 38 is in here, which will give me 3,000. We have 48 is here, which will give me 3,000 again. We have 90 where is 90? 90 is here, which gives me 4,000. Ladies and gentlemen, from there, we have 58. 58 is here, which gives me 3,000. So from there, go and pick the drag life in years, the drag life in years. Drag life in years, the first one is 97. Where is 97? 97, ladies and gentlemen, 97 falls here, you can see. 97 falls here, which gives me how many years? 9 years. 97, it gives me 9 years. From there, I have 99, and then falls here, giving me 10 years. 10 years, 10 years, 10 years. From there, we have 81. 81 is here. 81 is there. For my board, I have to be so sure. Now, ladies and gentlemen, we have here 81. Where is 81? 81 is right here. So 81 translates to how many years? 7 years. We have 09. 09 is right here, which translates to 4 years. We have 67. 67 is right here, which translates to 6 years. We have 70. Ladies and gentlemen, 70 is right here, which translates to 7 years. We have 75. 75 is right here, which again translates to 7 years. We have 83. 83 sits very well within this range, 83, which translates to 83, which again translates to how many years? 7 years. We have 33. 33 is well here, which translates to 5 years. 5 years. And then we have 10, ladies and gentlemen, 52. 52 is 52, 52 must be here. 52 must be here. 52 must be here, which gives us 6 years. Now, ladies and gentlemen, if it was a QA question, if this was a QA question, I would have really gotten it very easily, because after this, perhaps they would have told me to get profit. I would not have bothered. But because this is a it's a finance simulation question, I know I need, ladies and gentlemen, to discount. So for me to be able to discount these figures for purpose of getting net present value, I would want you, great students of mine, to assist me. I want the discounting factors. So I need to ask myself, is this cash flow, like the first one, the first cash flow, is it an annuity or a lump sum? Is it an annuity or a lump sum? Ladies and gentlemen, talk to me this morning. Is it an annuity or a lump sum?
The only thing the annuity.
Annuity, I'm being told annuity. Annuity, why? Because if you remember, in the question itself, they told us it's an annual after-tax cash flow. It's an annuity. So then to interpret this, I will have this is 3,000 to be enjoyed every year for how many years? For 9 years. To be enjoyed every year for 9 years. To be enjoyed every year for 9 years. The mistake that I realized very many students were doing, they were looking at these figures as if they are all of them together, and then they decided that these are what here? Irregular cash flows. No, remember that these runs are supposed to be independent. I'm supposed to get the NPV of run number 1 independently. So run number 1, I can see the cash flow is 3,000 per annum. And I'm going to enjoy this thing for how many years? For 9 years. So to be able to get the NPV, ladies and gentlemen, here, net present value, ladies and gentlemen, here, what I will do, I will take 3,000 times the PV for. Have they given us the cost of capital? Have they given us the cost of capital in this question? Yes, they gave us a cost of capital of 16%. So times PV for 16% for how many years? 9 years. For 9 years, and then we'll come and subtract the initial outlay. The initial outlay has been provided. The initial outlay from the first paragraph up there, the initial outlay is supposed to be 13,000. So minus 13,000. When I go to the second one, ladies and gentlemen, I'll pick 3,500 multiplied by PV for 16% will still remain. But this time around for round number 2, how many years do we have? 10 years. 10 years. And then we have here minus the initial outlay, which will remain at 13,000. Remember up there they have told us 13 million, but don't forget that even these figures are in shillings worth 1,000. So cut out the 3 zeros. Cut out the 3 zeros. So I want you guys to do me a favor. Get out your PV tables. Get out your PV tables, and then you read for me. Go to your PV table. Go to your PV table where you have PV is present value interest factor of an annuity. Where you have 16%, walk down until you get this 9 years. Until you get where N is 9 years. So please, the figure that is at the intersection there, the figure which is at the intersection here, the figure at the intersection there is the figure that you guys read for me. I want you to go to your discounting tables, the annuity tables, you pick 16%, go down with it. All the way, I'm trying to get the first one, all the way to where N is 9. Give me a figure to write. 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 So I'm interested in the PV first. At 16%, given the various number of years, so 16%, 9 years. Can somebody read for me that figure?
4.6065.
4.6065. Thank you, and thank you very much. How about the second scenario? PV for still 16%, but now N is 10. Number of years are 10. Number of years are 10. 16% versus 10. What do we have there? Somebody? You're simply reading. I don't want you to use the formula. You're simply reading. You're simply reading. So you go to 16% column, 10 years. 10 years, please read for me the figure that they have given us there.
That was, they haven't given another figure.
Okay. So please go to 16%, but 10 years. 16%, 10 years. And try to move with speed so we can utilize our early morning class effectively.
4.8332.
So somebody is giving me 4.8332. How about 16%? I hope you're together. If you're not together, please, I'm not here to waste your time. If you're not together, please simply say, Mwalimu, repeat something. Mwalimu, ask questions. Ask questions. Ask questions. But if you're together also, let us enhance our speed. So here we are talking of PV for 16%, but 7 years. What do we have? Somebody there?
4.0386.
4.0386. Please, how about 16% 4 years? 16% 4 years. 16% 4 years. 16% 4 years. 16% 4 years. Be keen to read very fast.
2.7962.
2.7962. Thank you very much. How about 16% 6 years?
3.6047.
3.6047. 3.6047. Move to the next one. Move to the next one. The next one is enjoyment, which is 7 years. I already have the one for 7 years. 4.0386. So this will be 4.0386.
A correction.
A correction, okay.
3.6847, not 6047.
It's supposed to be 3.6.
847.
847. Thank you. 847. 847. So we have for 7 years it will be 4.0386. Thank you. How about for 5 years? 16% 5 years. What do we have?
3.2743.
3.2743. And then, ladies and gentlemen, we have the last one for 6 years, which I happen to be having, which is 3.6847. So now create the last column of net present what here? Net present value. Create the last column of net present value. So how do we get our net present value? We discount the cash flows that we have. Let's discount the cash flows that we have. Let's discount the cash flows that we have. So the first cash flow that we have is 3,000 times the discounting factor minus the initial outlay of 13,000. Don't forget each of these runs, the initial outlay is 13,000. So like now for the first run, to get NPV of the first run, ladies and gentlemen, to get NPV of the first run, what I will do, run number one, I will come and give them the cash flow to be discounted is 3,000 multiplied by PV for minus the initial outlay of 13,000. Fortunately, we don't have scrap value. So then this will be 3,000 times the PV of 4.6065 minus 13,000. Who can give us this NPV of run number one very comfortably, very easily? Who has this figure for us?
819.5.
819.5. 819.5. Go to run number two, ladies and gentlemen. Run number two, what do you have here? I would want to discount the cash flow of run two. The cash flow of run two is 3,500. So 3,500 times the PV for run two is 4.8332 minus 13,000. Please give us a figure. So finished? Have they finished? Is there anybody who has been able to finish? So run number two, let's see. Run number two, what is the net present value that you guys have there? Run number two, kindly give me the run number two. Net present value for run number two. Net present value for run number two. Please talk to me. What do we have? 39?
3916.2.
3916.2. Thank you very much. How about the third one?
Someone has given 2903.5.
Positive or negative?
Negative.
Negative 2903.5. Go to the next one, ladies and gentlemen. Run 4.
Uh, 7406.
Negative,
7407.
7.6.
Negative.
Negative, yeah. So please try to check whether this figure is correct. Let someone else confirm that figure.
It's correct.
It's correct, eh?
7407.6.
Thank you very much. Negative. Go to the next one, ladies and gentlemen. The next one is supposed to be negative.
Negative 3788.25.
25. Negative. Thank you very much. Go to the next one. The next one, what do we have there?
$1135.1.
1135.1. Go to the next one. The next one will be
negative 884.2.
Mhm.
The eighth one is 884.2.
Thank you very much. Please, you are doing a good job. Go to the next one. The next one, the next one.
97.2.
Positive. And the 7.2. The last one.
Negative 1945.9.
0.9. Of course, if you read your question very well, ladies and gentlemen, if you read our question very well, what do they want us to simulate? Using the following random numbers, perform 10 simulation runs of the net present value of this project that you have done. And then number 2, determine the expected net present. Expected net present value is the same as average net present value. So please give us the total net present value. Please give us the total net present value. Come here and give us the total net present value. So what is the total net present value? What is the total net present value? What is the total net present value? Somebody? For us to get an average, we need the total. For us to get an average, we need the total. What is the total net present value?
One is giving negative 1184.
1184?
845. 845.65.
0.65. I hope it's all of them who are able to get this figure. Negative 11.
11%.
Only one person. Negative 11, 845. 845. Negative 11, 845.65. I would want someone else to confirm this figure. I would want someone else to confirm this figure. Someone to confirm the figure. Someone else to confirm the figure. Someone else to confirm the figure. Correct. Thank you very much. And therefore, the average NPV, the average NPV will be equal to that negative 10, negative 11, negative 11, negative 11, 845.65. You divide by what here? Somebody divide by 10. Divide by 10. So this one here will be negative 11, 84.565 is our average expected net present value, and therefore that project is not viable. That project is not viable because the expected net present value is negative. The expected net present value is negative. The expected net present value is negative because the expected net present value is negative. So if you allow me, I would want us to go to the next question. Next question. The next question of simulation is this one of November 2018. November 2018, question number 2. November 2018, question number 2. For those of you who have already bought our revision kits, ladies and gentlemen, for those of you who have our revision kits, RCM's revision kits, it's page number 4. Page number 4, Garanema. November 2018, question number 2, boy, Garanema Limited. Garanema Limited. So I don't want you to do, or rather, let us just start with part 1. So Garanema Limited is considering introducing new cheap plastic rulers into the market. This will involve investing in a new plant at a cost of 280 million. The plant is expected to have a useful life of 5 years, at the end of which the salvage value will be nil. The firm's policy is to depreciate. All of its fixed assets on a straight line basis. Due to market uncertainties, the unit selling price, unit variable cost, and annual sales volume of the new plastic rulers have been estimated stochastically as follows. So they have given us unit selling price, they have given us, ladies and gentlemen, unit variable cost, they have given us annual sales volume. Additional information, the firm expects to incur fixed operating costs, excluding depreciation, of shillings 30 million each year. The company's cost of capital is 17%. And then number 3, the corporate tax rate is 30%. Whenever we are given corporate tax rate, whenever corporation tax rate exists, ladies and gentlemen, we must compute depreciation. Depreciation becomes relevant. So they want us to give them the proper cash flows, which will enable us get expected net present value. I'm giving you exactly 5 minutes, and then you tell me whether you'll be able to see where that question is headed towards, where it is going,